Welcome to CR275 Week 1, bit of a fly through for you. So this is what we're going to be doing. We're going to be doing unit information and going through the plan, the structure, science and technology curriculum, and we're going to be looking at examining some experiments that we'll perhaps be doing either at home or in the classroom today. So let's dive into it. And the first thing I want you to do in class is to do a discussion. Now, if you're at home and online, get you to think about these things. How do you rate your knowledge of science from your own experience? How's it taught? And how should you teach science and technology? What's some maybe 2 or 3 things that you put those first two questions together and say, I think you should teach science this way. And then I'll get you to paste those words to that word cloud, and we'll see what that develops and be able to link to that word cloud through that. And do kids like science, technology? I reckon they really do, because it's one of those very practical activities. And if you're after an interesting subject, then get yourself into science and technology. So we're going to do our class. We're going to start with a bang. If you want to look up that, get some bicarb soda and a sealed bag and give it a bit of a go. Make sure you're outside perhaps for that. And maybe we'll do a little bit of something like this, maybe not quite as wild as that, but as a bit of a hook and interesting things. But also we're then going to talk about how does these things work as a little example about science. And then the technology link is, well, okay, if these things work this way, how could we perhaps harness those? And that's where technology is about. And so when we look at the curricula and we see the word, science and technology, I know you've heard about STEM. Now, STEM stands for science, technology, engineering and mathematics, and how they fuse together to make an authentic learning activity. So we'll do some of that as we go along. We won't be just teaching science and just teaching technology. You've done separate subjects on those already, one on science knowledge and one on technology knowledge, but a little bit of curriculum. This one is going to look at that. It's probably a little bit larger statement on science, because you looked at curriculum a little bit more fulsomely in technology's curriculum and technology unit. So we're probably going to go through there. So how do you become a great science tech teacher? We're going to have some discussion and activities on that, and I'm encouraging you to be knowledgeable. Beef up your understanding of things. So and have a look at the curriculum to see what areas are covered, and be passionate. The kids will mirror how you are. So if you're interested, passionate and excited, your science and technology lessons will similarly be that way. And I've said something with here, pose a big question. Don't just do it from, here's the stuff you need to learn. Pose a big question. Tell me, why does the sun always look yellow and the sky blue in the middle of the day, and sun looks orange and the sky and the clouds look red and orange at the end of the day? Now that might be an introduction to Earth and space and the sun and the moon. Or do an activity with a bag like we did and hook them into something, or a story, or grab an event that's happening in the world at this time. When they're talking about fires and floods, well, that'll link to a unit on natural disasters, which is part of the curriculum, for example. And link, how would I solve this? How could we do things? What would be a solution to that? Well, it might open up a technological solution, and you hook them in with those things there. Think student-centric. Rather than skills, knowledge, think what is in the student's world, and that will get high engagement. And that links with maybe using a current event, something in their experience that you might use, and something when they've done in their own world. Mix up your teaching strategies. That's probably common for all learning areas. But, there's videos to watch, there's things to read, there's things to reflect, there's things to do. And if you mix up a whole lot of range of strategies, then you'll obviously get them more highly engaged. And here's I listed some of those things there. Now, in class, we're going to do a little bit of that. At home, I'll get you to log on to that video and have a look at those and find out what is some of the science and technology, and what are some of the why for these things to occur. So do a demonstration in class perhaps and see what happens with that. Sorry, I had to pause the video. I'm not sure if I communicated. We're going to do this in class if you're on campus, or have a look at that YouTube and you can have a look at that experiment, or have a go at home. It's not a difficult one. It's a very simple one, and it's a science topic. So we're going to use that as an example for our discussion in class about how things are run. This slide here is now saying, okay, we've had a play. Hopefully I've hooked you into science and technology by things that we've done. And now we're saying, okay, let's refer to our program outline. And you notice I've got like an image there, but it's also under unit information. And the yellows are labs. Now they're lab sessions that two of them are at top here, City Point S6, and these are one in classroom, because as a primary science teacher, sometimes if you're in a P12 school, perhaps you might have access to a lab. Most primary science teachers don't. So we've really got to do what I call kitchen science, where you've got water, you might have some wet area to do, and you can get simple materials. So some of the science labs that are in class are more of those types, as opposed to the lab work, which we're actually going to be doing more of those experiments that we do. Not complicated, but simple experiments which you might have the opportunity to do in your teaching, and it relates directly to assessment task 1, because the lab assessment task 1 is a lab report based on the experiments that we do. And on the right hand side here are when tasks are done. I'll go through assessment shortly, but this slide might help illustrate it. Assessment task 1A is a formative assessment. So I'm going to get you to do the microscope lab and write it up as a scientific report. And I'll give feedback to everyone on how that was. Now, task 1B is a summative report. That means now it's going to count. So by the time that's due, you would have done lab 1, lab 2, and lab 3. So that's your task 1. Following on that, we've got other bits and pieces, but we've got task 2 and task 3 are related, and I'll talk about those when we get to the assessment discussion slide. So this is what is interesting. Weekly schedule is important. Unit outlines there, and here's the assessment. And I've just gone and packed those things, and their due dates are those. Now, the assessment task 2, which is down here on the graphic, is a scientific investigation and report. So I will organise you in groups of 3 or 4. Now, you will do a scientific investigation, different to a prac. It's a little bit more investigation, it's more broadly, and I'll give you scaffolds and a template for that is found in the unit outline, but I'll update that when we get closer to that time. And you'll then do that investigation and you'll write it up. Every person in your group will write an individual report. Now you will share common aspects of the report. In other words, all your results and things that you do are all going to be the same because you did that as a group. Your method of writing what you did and how you designed your experiments are all going to be the same because you did it as a group. Some of the introduction comments about the theory, some of the discussion on what this means is you're going to be completely your own work and so on. So that is going to take a little bit of time. Now, depending on what you're doing in terms of a science or a technology related area or a combined STEM area, it might be a one-day get this done. It might be a longitudinal one in the sense you might have something that is growing, and that might take a few weeks of growth, and you're measuring and collating that information or so on. Or you might do a tech thing, you do one session, the next session, and the next session. So because of that, I'm recommending that you start it in week 4. And it's due just before you go on prac. Prac is week 13 to 15. So that's what you do. And I've made it due then. Now, investigation 3 is related to investigation 2. Why? Because in task 3, you're going to present the findings of your investigation in number 2. This is what we did, this is what happened, these are all our conclusions we've drawn, for example. But then you're going to have an additional one where you choose one of your practical aspects that you did as a demonstration in class. with a group of people. So you get the group to do the work, or you're demonstrating and get them to interact with the learning. So it is reporting on task 2 as a presentation and having a demonstration of an activity that you did as part of that. Now, it doesn't have to be the whole activity of report, but it might be one aspect, and it's like it was a lesson. So if you're doing an investigation on motion, and you've got some technology you're doing and how to make this go fast, further, higher, lower, whatever it is, then what was one lesson that you would have had in a class as part of that investigation? And you demonstrate it, and you've got to present a lesson plan. That is in the exam block. Now, a few I mentioned in the overview, the pracs I come to. Now, if you're online but live within 50 to 100 Ks, then I'd like you to prioritise that, see if you can rearrange your work schedules, etc., and to come to those prac sessions, particularly 1 and 2, the lab sessions. Also, in exam block, it'll be, that won't be finalised until the latter part of the semester, but it'll be in week 17, we will have a presentation. And again, if you are in range of CHC, I need you to come as part of your group to do that presentation together. So on campus, mandatory, online, but able to come, consider it mandatory. If you've got some exceptional circumstances, let's have a conversation about that. I live in Melbourne. Okay, we're not going to fly you up for this, so therefore we will give an alternate presentation where you'll perhaps will be videoing, or you'll be streaming in at that time to your part of that. So your group will allocate you a task, and you perhaps will stream in, or you'll have a video and they'll play your video section as part of that demonstration. So there's an alternate way there. Next bit we go on is about the science curriculum, and in the science curriculum are the areas, and you notice there's the content areas here, and it's got to do with real world, and that's a real big push about here as a human endeavour. And there's all the inquiry methodology. This is science because this is how we do things, and evidence and proof and controlling variables, etc. So we'll dive into the Australian curriculum a little bit in the first session, and also we'll dive into the technology curriculum that is there. And notice that the technology area that works best with science in terms of a STEM context is in the process and production skills. You're not going to be doing necessarily much digital. It's going to be integrated. Digital tools will be integrated into what you do, but we're not going to be examining digital things like we did in, say, the technologies unit. But we will look at more fulsomely the links between the technology in terms of how we investigate. And if you can recall from the technology one, there's a cycle of, we use the science engineering cycle about technology, how you imagine, and then you plan, then you enact, and then you refine. And there's a couple of things like that. So that's relating to the process and skills. So if we go back and see that the inquiry skills, planning, conducting, modelling, processing, analysing, evaluating, matches quite, there's a big overlap in here. So the design technology area is the technology that's most used in STEM. Now, digital technologies are that integration of technology in the creating, in the communication areas of that. Last is your take-home. So online, you have a take-home work to do. In class, we'll start this in class and perhaps see your take-home activity. And that is really to look at a number of little experiments, and I'll have links to those things on week 1. And you've got to go through and say, what is the curriculum link to technology? What's the curriculum link to science? Is there any other STEM links? And you're going to now start thinking like a scientist and say, what are the variables? What are the things involved here? For example, time. We're measuring it over time. Or distance is an outcome that we want to do. Or growth is an outcome we want to do, or an observation. What are the things in this experiment that you can change? Variables. Choose one variable, state your hypothesis, and I'll going to go through this in more detail in number 2, but have a go. So I don't expect some of this to be fully answered, but we will review this as the first step in lecture number 2. And I want to, in lecture number 2, accentuates this idea of a fair test and control variables. How would it make your tests reliable? So if we're doing the balloon one, how would we do the balloon one? So have a click on the link, see what it is. How would we make this a reliable test? How would we do things? How do you record the results for this one? Different to the results for this one, making clouds, for example, or growing carrot tops. And how long would you use this? So with carrot top, for example, spoiler alert, it's going to take more than one lesson. There you go. How long would you do this for? How long would you do that for, this one for, and this one here? So that's a bit of a organizing tool to get you to think about what's behind these experiments. Then what do I need to know about to effectively do that in the classroom? And how is it linked to the curriculum rather than just a big fun activity? Well, it can be a fun activity, the curriculum, but what are those links? And that's the finish of what we're doing this week. There's my details. So that's week 1 fly through. For online class people, make sure you've done that, looked at those information, done the activities, and looked at the fly through before we come to our tutorial on Wednesdays. For my on-campus people, have a look at that fly through before you've come to class, please. Thank you.